Hi students, good morning. In Artificial Intelligence subject, Unit 1 to 4 are completed. Now today I will start the Unit number 5, Probabilistic Reasoning. Okay, in this unit we can learn the probability and bias theorem, then certainty factors and rule-based system, then Bayesian networks, dumpster Shapper theory and fuzzy logic. Okay, these all topics are given in the unit number 5. So today I will start with the introduction. First the basic introduction is given, then in the statistical reasoning the probability and bias theorem are given. So here we can describe the several representation techniques, okay, but here we can use some model for belief the system in which any given point in the time the particular fact is believed to be true. Okay, we can take some facts and we can find out the given fact is true or false. Okay, and for checking we use some method or algorithm or technique. Okay, but for some kinds it is useful to be able to describe beliefs that are not certain but for which there is some supporting evidence. Means here we can't describe all the beliefs. In maths you can take some equations, okay, there is no proof are given but we can use that equation. So here some beliefs or facts which can have not proper explanation but we can accept that facts. Okay, for example, problems that contain genuine randomness, for example card game. In the card game the problems are specified, okay, and we can play the game by using the rules. Okay, we all are play the card game and we all are know that many sub games are present and we can randomly play the game. Problem that could in principle be modeled using the techniques that we use in uncertainty. And in the unit number 4 we can learn the uncertainty. Okay, so here we can use that concept of uncertainty and we can find out the techniques or principles. For such problem, statistical measures may serve a very useful functions as summaries of the world. Okay, and in some problems we can take some functions, okay, and we can summarize the world and we can look for all the possible exceptions. We can use a numerical summary that tells us how often an exception of some sort can be expected to occur. Now here we can find out all the possibilities. If some problem is given and we can find out the all possible solutions for that problem and we can select the best solution for the problem. So here we can use the numerical summary, number summary. Okay, next is this is useful for dealing with problems where there is randomness and unpredictability, such as game of chance. and also for dealing with problem where we could, if we had sufficient information, work out exactly what is true. Now we can deal with the problem. Okay, we can find out some randomness, means what the basic rules are given and what are unpredictable, means we can't guess the problems, but the problems can occur. Okay, so here we can find out that problems and we can solve that problems. To do all this in a principal way requires technique for probabilistic reasoning, and here we can use the probabilistic reasoning for some principles. Okay, and for that some basic requirements, basic techniques are required. So here we can learn one by one all techniques. Okay, in the statistical reasoning, first we can learn the probability and bias theorem. So first the basic introduction is given, then one equation is given for bias theorem. Okay, and all terms which are present in the equations, its explanation is given. Then one example is also given. Okay, in probability theory, bias theorem or bias rule describe the probability of an event based on the prior knowledge of conditions that might be related to the event. Now here in the probability theory, we can use the bias theorem or bias rule and we can describe the probability, its events, okay, and find out the knowledge, and we can find out the conditions which are related with the event. Now the bias theorem is expressed in the following formula. We can describe the bias theorem by using this formula: P of A by B is equal to P of B by A into P of A divided by P of B. Okay, and in the equation P of A by B, the probability of event A occurring given the event B has occurred. We can have the event A, okay, and we can find out the probability, means ઇવેન્ટ એ છે તો એ કેટલી વાર આવશે એની આપણે પ્રોબેબિલિટી મીન્સ એના નંબર ફાઇન્ડ આઉટ કરવાના છે, અને ઇવેન્ટ બી કેટલી વાર આવશે તે, બરાબર. શેમાં હશે? પી ઓફ એ બાય બી. નેક્સ્ટ શું છે? પી ઓફ બી બાય એ. ધ પ્રોબેબિલિટી ઓફ ઇવેન્ટ બી occurring given that event A has occurred. First, event B has occurred and then event A has occurred. Okay. Next, P of A, the probability of event A. P of B, the probability of event B. So here we can find out all the four terms which are present in the bias theorem, and we can find out the all terms. Okay, now suppose in a school with 100 students, out of those 55 students study maths. Okay, here one example is given. School has total 100 students, and from 100 students 55 students study maths, so we can take as a event A, and 25 students study biology, so we can take as a event B, and 20 study both. means here P of A by B is equal to probability that a student studies maths given that he studies biology. Means P of A by B એમાં શું છે કે કેટલા સ્ટુડન્ટ્સ મેથ્સની સ્ટડી કરે છે તે બરાબર. અને ત્યાર પછી શું આવશે, મેથ્સ નથી ભણતા મીન્સ બાયોલોજી ભણે છે અથવા તો બેવ સબ્જેક્ટ ભણે છે, તો એ આપણે લેવાનું છે P of A by Bમાં. ત્યાર પછી P of B by A, probability that a student studies biology and given that he studies maths. બીમાં શું છે કે જે બી સ્ટુડન્ટ્સ બાયોલોજીની સ્ટડી કરે છે એ લેશો અને એના સિવાયના શું કરશે, મેથ્સ ભણતા છે બરાબર, એટલે B by A આ રીતના લખશું P of B by A. નાવ સપોઝ ઇફ વી વોન્ટ ટુ ફાઇન્ડ what is the probability that a student selected randomly studies maths given that he studies biology also. હવે 20 સ્ટુડન્ટ્સ એવા છે કે જે બેવ સબ્જેક્ટ ભણે છે બરાબર, તો અહીંયા આપણે શું કરશું, એના માટે બી આપણે બતાવવું તો પડશે બરાબર કે એવા સ્ટુડન્ટ્સ કે જે બેવ સબ્જેક્ટ ભણે છે, તો એના માટે આપણે કઈ રીતના લેશું, એઝ પર ધી કન્ડિશન પ્રોબેબિલિટી પ્રીડિફાઇન P of A by B means A given B is equal to P of A intersect B divided by P of B. P of A by B ફાઇન્ડ આઉટ કરવું હોય તો એના માટે આપણે આ ઇક્વેશનનો યુઝ કરશું બરાબર. ઇન્ટરસેટ અને યુનિયન મેથ્સમાં આપણે ભણી ગયા છે બરાબર, તો P of A ઇન્ટરસેટ B જે બી આન્સર આવશે એને ડિવાઈડ કરવાનું છે P of B થી બરાબર. ત્યાર પછી છે P of B by A, B given A, એના માટેનું ઇક્વેશન શું છે, P of A ઇન્ટરસેટ B ડિવાઇડેડ બાય P of A. ઓકે, તો આ બે ઇક્વેશનનો યુઝ કરીને આપણે P of A by B અને P of B by A ફાઇન્ડ આઉટ કરશું. ત્યાર પછી હવે આપણે બાયસ થિયરમ એપ્લાય કરશું. તો એના માટે શું થશે, પહેલાં જે ઇક્વેશન આપેલું છે ઇક્વેશન લખશું આપણે. ઇક્વેશનમાં શું આપેલું છે, P of A by B is equal to P of B by A into P of A divided by P of B. ઓકે, હવે P of B by A તો એમાં શું લીધું 0.20 મીન્સ P of B by A એમાં શું કરવાનું છે, A ઇન્ટરસેક્ટ B. તો 20 સ્ટુડન્ટ્સ એવા છે કે જે બેવ સબ્જેક્ટ ભણે છે, એટલા માટે આપણે અહીંયા આ ઇક્વેશન જે છે બેવ એના પરથી આન્સર ફાઇન્ડ આઉટ કરવાના છે બરાબર. P of A ઇન્ટરસેક્ટ B. ઓકે, અને અહીંયા વેલ્યુ મૂકવાની છે, P of B by A વેલ્યુ કેટલી આવશે 0.20, P of A આવશે 0.55, P of B આવશે 0.25. ઓકે, P of B by A એટલે 0.20 ડિવાઇડેડ બાય 0.55. ઇક્વેશન શું છે P of B by A નું, P of A ઇન્ટરસેક્ટ B ડિવાઇડેડ બાય P of A. તો P of A ની વેલ્યુ કેટલી છે 0.55, એટલે આ 0.55 તો અહીંયા આવ્યો જ, પણ 0.20 જે આવ્યો એ શું છે, P of A ઇન્ટરસેક્ટ B એની વેલ્યુ છે 0.20 બરાબર. તો એના પરથી આન્સર આપણને મળશે P of A by B નો 0.8. સેમ આપણે કરવાનું છે P of B by A માટે બરાબર, અને એના માટે પણ આ રીતના આન્સર મળશે આપણને 0.36. So here the bias theorem is used in various disciplines like statistics, medicine, management, different fields of finance, etc. યુઝ આપેલો છે બરાબર. બાયસ થિયરમનો આપણે યુઝ કઈ કઈ જગ્યાએ કરીએ તે, તો આ બધી અલગ અલગ ફિલ્ડમાં આપણે એનો યુઝ કરીએ છીએ. So here our first topic, probability and bias theorem, is completed. Now second topic, certainty factors and rule based system. Okay, this topic I will explain in the next video lecture. Okay, today I will start the unit number 5. First I will explain the basic introduction, then I will start the statistical reasoning. In this topic I will explain the first topic, probability and bias theorem. Here the equation is given for bias theorem and we can take one example and learn the bias theorem. Okay, now in the next lecture I will start the next topic. Okay, thank you.